This formula has to be translated to conjunctive normal form and disjunctive normal form. For this translation, we learned about an algorithm that you can see on your screen. So the first step, eliminating XORs, the second one, eliminating equivalences, the third step is eliminating implications. If you look at the formula, you cannot see XORs, you cannot see equivalences, but you can see implications. So we have to eliminate implications first. You already know how to do that. It's easy. Basically, you replace the implication with disjunction, and then you negate the left-hand side and keep the right-hand side. We can do the same to the other implication, and we have to copy everything else. So this whole formula was negated and connected to the negation of the other formula, and with the conjunction between. Okay, it looks a little bit messy, but I hope you can follow it. Okay, in the next step, of course, we have to do something. We must do something with negations. Here we have negations outside of parentheses, and similarly we have negations here. So this rings some bells that we must deal with them. We must eliminate them. I cannot find the algorithm. Here it is. Yeah, so now the next step is dealing with negations by applying De Morgan laws. Whenever you have a negated conjunction or disjunction, you just eliminate the parentheses. You know what it means. The operator flips, and also you have to negate both operands. So this is what we are going to apply right now here. Okay, but the question arises, should we apply to this the first negation or the second, or which one? Well, my suggestion is to try to apply it to the first one. Okay. Oh, sorry, to the first one. So this one and only this one. Okay, so this means that we turn the disjunction to conjunction, and also we negate the left operand, which is great because the other negation disappears like a charm. And also we have to negate the second operand, and then another negation disappears. This is really great. So this is what we get. And also, if you look closely, we can eliminate those parentheses because conjunction is associative, so we can it doesn't matter in what order we apply those conjunctions. Okay, let's do the same trick to this negation, and you can guess it that we get the following formula, which is really great. And actually, both of them are connected with this conjunction in the middle. I eliminated all the parentheses. We don't need any parentheses here because we only have conjunctions. Furthermore, of course, we can simplify further. Let's simplify whenever we can. So this is what we should do here. Of course, we can eliminate duplications like those. And what we get at the end is P and Q. This cannot be simplified further, and the question arises, is it in CNF or DNF? Well, it is definitely in CNF, since in CNF the main connective is conjunction. So yeah, this is a CNF which connects actually two clauses, each of which includes a single literal. So this is a CNF. This is easy to see. On the other hand, this is also a DNF. Why is that? Because we can consider P and Q as one single cube, which is now connected with nothing. So basically, this is a DNF which contains one single cube, P and Q. To summarize, whenever you get a formula at the end which contains only conjunctions, then that resulting formula is a CNF and a DNF in one. The same happens if you get a formula at the end which contains only disjunctions. This is also both in CNF and DNF.